Okay, these are our notes for section 2.6 on algebraic proofs. First thing we're going to do is we're going to get a definition and the setup for a two-column proof. Now a two-column proof is just exactly what it sounds like. It's going to have two columns and we're going to work through a problem to prove an answer. Now these two columns have names. The first one is always the statement column, and you need to label these. Okay, statement column. And the second one is the reason column. Now the big idea for a proof is that whenever you make a statement, you need to tell me why you're making that statement. So we need to give a reason for it. You make a statement, then you're going to tell me why. Why is that true? Alright? And every statement needs to have a reason. That's why these are numbered in our proof setup. Now you may have more than 5. I just put 5 on here as a general number. You may have 10, you may only have 3. That's okay, but you need to number every statement so that it pairs up with the reason, and they should go in order. Now our very first statement is always the problem or your given information, and you just rewrite it there. And that'll make more sense when we do an example. Today it's all going to be problems. We won't have given information today. That'll be on a different section. But we're going to rewrite our problem here. And the reason for the first step is always given. And you write the word given. Okay? Because I gave that to you in the problem. And then we work out our problem. We go through and number our steps. And the last step, in this case it's going to be step 5, is going to be the answer or what you're trying to prove. Okay, that's always your last statement. The reason will be different for every problem because the reason or how you got that answer is going to be different for every proof. But that last step, that last statement, should always be the answer or your proof statement. Today it's going to be the answers to our problem. Now, a proof is a good example of deductive reasoning. Remember, there's two types of reasoning. Inductive uses specific examples, and then you come to a generalization. Deductive, you are working through a problem, and you're going to get down and you're going to deduce the answer. You're going to come up with one solution. So you're going through it step by step. Now, in order to do these problems today, there are 7 properties that you need to know. And we're not going to use all of them today, but we're going to go ahead and fill in our properties chart with all of them. The first one is the reflexive property. Okay, and what it really means, I'm going to give you a basic layman's terms example for it, is that a number equals itself. Now this is the one you're probably not going to use today, but here's an example. I could say 3 equals 3. I have 3 and 3 is going to equal itself, so 3 equals 3. One way to help you remember that reflexive sounds an awful lot like reflect, and when you look in a mirror it's the same thing as it's the same as your face. So here 3 is on one side, 3 is on the other. It's exactly the same on both sides. Okay, reflexive, a number equals itself. Symmetric, this is an important one. It means that you can switch sides with an equal sign. And our key word here is going to be switch. Alright, here's an example. If I have 3 equals x, then according to the symmetric property, I can make it x equals 3. And that's going to be really important because all of our answers for these algebraic proofs always need to have the variable on the left. If they don't, we're going to have to use that symmetric property to switch it around to get the variable on the left and the number on the right. The transitive property, and I like to call this one the middleman. The transitive property says if I know that a number A equals B and I know that B equals C, then I can just get rid of these two in the middle That's where I get the middleman, because it's the same on both. And I can just say A equals C. I can cut out the middle part and just go to the two ends. Here's an example. If I know that 2x equals 3y and 3y equals 8z, then I can just get rid of all that stuff in the middle, and I can say 2x equals 8z. Now this is another one. You're not really going to use this today. It'll be more important when we get to geometric proofs. Okay, same thing for reflexive. But I'm going to go ahead and give it to you today so you know what it is. The rest of these properties you should know. Okay, you use them all the time in algebra. First one is the addition-subtraction property. And it says if you add or subtract to one side of an equation, then you have to do it to the other. So if I have a problem like x plus 2 equals 3, I can subtract 2 from both sides, and I get x equals 1. The fact that I'm subtracting 2 from both sides, that's the subtraction property here. I'm doing it to one side, I have to do it to the other. Multiplication division is the same idea. If you multiply or divide to one side, then you need to do it to the other. Here's an example. 2x equals 8. I'm going to divide both sides by 2. That's the property here. Okay, so then I get x equals 4. I divided on one side, so I have to do it on the other to keep them equal. Substitution means that we're going to replace something. Okay, we're going to switch something out. So suppose I've got, here, let me write it over here. Replace. Here's your example. Let's say that 2x equals y. And I know that x equals 3. I can use my substitution property because now I know that x equals 3, so everywhere I see an x, I can switch it out and put a 3 in its place. And then I get y equals 6. Or in this case, 6 equals y. And we'll switch it around using the symmetric property to get y equals 6. Substitution is pretty similar to transitive. A lot of people get them confused. Just remember, for the transitive, the middle parts need to be the same. But for substitution, I know that a variable is going to be a specific number, so then I can just switch it out for every place. I can replace that variable with a number in every problem, every place I see it in the problem. Okay? Last one is the distributive property, and this one's you should know already. Okay? If we have A and it's being multiplied to a set of parentheses where two things are being added or subtracted, we have to take that A and it gets multiplied to both. So it becomes AB plus AC. Here's an example. 3 times x minus 1. That 3 has to go to both of them. So it becomes 3x minus 3 times negative 1 is 3. Okay, negative 3. So we get 3x minus 3. Now we're going to use all those properties to do two examples. Example 1 here is 3 times x minus 2 equals 42. And we're going to set up a 2-column proof. Alright, first column, remember, is the statement column. The second column is a reason column. And our first statement is always our problem. So we're going to rewrite 3 times x minus 2 equals 42. And our first reason is always given. Now what we're going to do is we're going to go through step by step on this problem and show every step of work until you're going to tell me what your reason is for doing each step. And it's going to be one of those properties that we just talked about. So step 2, first thing we need to do is distribute. So we get 3x minus 6 equals 42. And we got that from the distributive property. Now your next step would be to add 6 to both sides. Okay, since we're adding to both sides, that's the addition property. Now we're going to rewrite our problem, and we get 3x equals 48. Now this step can be confusing. We are rewriting that problem, and whenever we rewrite, it's going to be substitution. Okay? Anytime we rewrite that problem, it's substitution. Step 5 now is going to be to divide both sides by 3. We're doing it to both sides, so our reason is division. Step 6, we're rewriting that problem again. We get x equals 48 divided by 3 is 16. Now we rewrote it, so our reason is substitution. Okay, and then we've got our answer. Notice that the x is already on the left, so we don't need to flip it around. We don't need to use the symmetric property. We've got our answer here, and then we're finished. There's the answer to our problem. Took us 6 steps to get there. Let's do another one. Here's example 2. Set ourselves up a 2-column proof here. Again, the first column is the statement column. Second column is the reason column. First statement is always rewriting the problem. 1 equals 5 minus 2/3 z. And the first reason is always given. Alright, step 2. We need to do something. We got to get z by itself on one side. So I'm going to subtract 5. Now there's different ways to do this problem. You could do something else first, and that's okay. It may take a few more steps. You may do it in less steps than what I did. So it may be different, but you're going to get the same answer, same end result. Alright, I subtracted 5 from both sides. That means our reason is subtraction. Step 3, we're going to rewrite our problem again. 1 minus 5 is minus 4 equals negative 2/3 z. We rewrote it. Okay, this is the tricky step. We rewrote it, so it's substitution. Now, real quick word of caution. You cannot just write sub for subtraction or substitution. I want the full word because they're very similar. Alright, and if you just write sub, I'm not going to know which one you're doing. Step 4. We got to get rid of that fraction somehow. So I'm going to multiply both sides by the denominator. Multiply both sides by 3. Since I multiplied on both sides, our reason is multiplication. Step 5 again. We're going to rewrite it. Negative 4 times 3 is negative 12 equals, now our 3's canceled each other out, so we get negative 2z. Okay, we rewrote the problem, so this is that substitution again. Notice we use substitution a lot on these algebraic proofs, because anytime we have to rewrite that problem, it's going to be substitution. So it's pretty much like every other step. Okay, step 6. We need to divide both sides by negative 2. Since we divided on both sides, our reason is division. Now 7. Okay, we're rewriting it again. We'll go ahead and put the reason down. We're rewriting, so it's going to be substitution. Negative 12 divided by negative 2 is positive 6 equals z, because our 2's canceled each other out. Now on this one, that variable is not on the left. We got to get it on the left, so we're going to switch it around. We're going to say z equals 6. Now think back to our properties. Which property was the one that we could switch places around an equal sign? That was the symmetric property. So that's the last reason here. And we got the answer. Z equals 6. And there's the answer to our problem. We did that one in 8 steps. Now, you could do it a different way. You may move the negative 2/3 to the other side to get it over there first. That will change your steps. You're still going to, but it's going to change the steps and maybe the amount of steps it takes to get there. It may be fewer, it may be more, but you should get the same answer. You should get 6 as your answer. And those are your notes on section 2.6 on algebraic proofs.